Hello and welcome to Module 6 in our Angular series. Let's look at what we're going to cover in our session today. We're going to start by revisiting the Angular Input Directive, and you may recall that we've used this directive in order to share data from the store component to the cart component. The purpose of revisiting the Input Directive is to refresh our memories in terms of how it works, and then to introduce the Angular Output Directive and the Event Emitter class. We will then discuss Angular's two-way data binding, make the case for two-way data binding in our project, tweak the code to adopt two-way binding in our project. We'll also discuss Angular lifecycle hooks, OnChanges and DoCheck. And finally, we will use Angular animations to create dismissible alerts. So let's begin by revisiting the Angular Input Directive. The Angular Input Directive allows for data to flow one way from parent to child. We currently have this selector, which is a selector of the cart component in our store view file. Right now, once we put in the selector of the cart component into the store view file, it became a directive, right? And within that directive, we are saying or specifying that the property from the cart component, which remember is a property that is decorated with the input decorator, be assigned the value of the property from the store component, right? Remember again that the cart component in our project is the child and the store component is the parent. And so we have one-way data flow from the parent, which is the store component, to the child, which is the cart component. The box brackets are what is referred to as input binding. Now, what if we wanted data to flow in the opposite direction, right? From child to parent. In that case, we would have to make use of Angular's Output Directive. The Angular Output Directive works so as to allow for data to flow in one direction again, but that's from child to parent. How it works is different from the way the Input Directive works. In the case of the Output Directive, the child component would have to raise an event using the Event Emitter class in order to send or communicate data to the parent component. Now we've learned about Angular event binding, right? We've seen Angular event binding at work, specifically using the click event, right? We know that with the click event, when the user clicks on a button, for example, an event is emitted or an event is raised, which triggers the execution of a function, for example. In the case of the event raised with the output directive, though, this event is not raised in response to any user action. Rather, the child component would raise the event using a method called the emit method, which is from the event emitter class, and this method would not only raise the event but also emit a value that could then be sent or communicated from the child component to the parent component. To sum up then with the output directive, we would have to declare a property decorated with the output decorator and also declare that property as an event emitter type. Once we declare the property as an event emitter type, what we are actually doing is we are creating an instance of the event emitter class. And once we create an instance of the event emitter class, we have access to the methods of that class, and then we can use the emit method from that class, that is the event emitter class, to, like I said, not only raise the event, but communicate the value to the parent component. So I hope the way the Angular output directive works is clear. Now, what if we wanted data to flow both ways, that is from parent to child and child to parent? In that case, we would use Angular's two-way binding. And as is indicated here, that allows for data to flow both ways, from parent to child and from child to parent. And all we need to do to include two-way binding in our application is to use a combination of input binding and event binding, right? And the syntax itself is a combination of these two and is referred to as the banana in a box syntax. So banana indicating event binding, in a box indicating input binding. I hope this is clear. Now, can we use two-way data binding in our project? Let's look at what's currently happening. We have the user being able to add items to cart from the store component, right? But we also have the user being able to change quantities in the cart, right? Being able to decrease quantities, increase quantities, remove items from the cart, right? The prime candidate then for two-way data binding in our project is cart quantity. Why? Currently, cart quantity is being updated in the cart component, specifically when the user is changing quantities in the cart using HTML. Now we're going to see how we can use Angular instead to have that value updated. How will we do it? We will import output and event emitter class in the service. We will then declare output properties as event emitter type so that we have access to the methods of the event emitter class. We will then use the emit method of the event emitter class to communicate the change in property value. In our case, the change in cart quantity. In the child, which is the cart component, we'll import the output directive, but notice that we don't import the event emitter class. Reason being that our logic is all in the service and any change in cart quantity is going to happen from within the service file, right? The reason that we need to import the output directive into the cart component is to make the output property that we declared in the service visible to the cart component, and of course inject dependencies into the constructor. In the parent, which is a store component, we'll use two-way data binding or banana in the box syntax in order to complete the two-way data binding for the property, which again is cart quantity. Now, of course, we need to go and put this into code. Before we do that, let's summarize the input and output directives. Both the input and output directives are the application programming interface of the child component. Application programming interface is a set of procedures and functions that are available for an application to use, right? The second statement says the input and output directive act as ports in and out of the child component. So what does that mean? So here we have the input directive which allows data to flow to the child, and we have the output directive which allows data to flow from the child. Therefore, the input directive is a port in to the child, and the output directive is a port out of the child. Right? So I hope that's clear. Now let's go ahead and implement two-way data binding in our project. To load the project, you know what to do. Either you could use VS Code, and if your project features in the folders and workspaces, click on the folder and that should open up Visual Studio Code along with your project. Alternatively, as you know, you could use the node.js command prompt, click open, change directory to your project directory, and then type in code space dot to load Visual Studio Code along with your project. Once the project is loaded, come straight to the track order quantity service file, and we'll start by importing what do we need to import? The output directive and the event emitter class. Now, do we really need a separate import statement? As you can see here, we already have injectable being imported from Angular core, so we can put it there, right? Output, event emitter, right? Once we've done that, we can now declare our property. So at the rate output, remember we need to decorate it with the output decorator, right? And then the name of the property, so cart QNTY change. And now we need to declare it as an event emitter type. So equal to new event emitter, okay, and it's going to emit a number, and that's how we declare it. Right, so we are creating an instance of this class. Once we have that, we can now use the methods from the event emitter class, right? So in our functions related to the modification of the cart itself, which is update cart add and update cart subtract, after the statement which says this dot cart quantity plus plus, we will say here this dot cart quantity change dot emit, right? And we need to specify which property is changing value. Which property is changing value here? The cart quantity property, right? So cart QNTY, right? And now we need to just copy that statement. So Control C and paste it in the next function, just after this dot cart quantity minus minus, right? So I hope you've understood what we've done here. We've imported the output directive and the event emitter class. We then decorate the property with the output decorator and have it declared as a new event emitter class type, right? Once we have that instance of the class created in cart quantity change, we can use the methods of the event emitter class. And so within both the functions where the user is allowed to modify the cart, we are using the emit method, which will raise an event and communicate the changed cart quantity to the store component, right? Now, coming to the next thing that we need to do, come to our cart component TypeScript file, and we need to import the output directive here as well. So we can put it straight up here after input, comma, output, right? And then we just declare the property with the output decorator, and it needs to be the same property as we have declared in the in the track order quantity service file, right? So cart QNTY change, right? And here we say the dependencies, this dot cart QNTY change equal to track odd quantity service dot cart QNTY change. Okay. Now the next thing we need to do is to put in the banana in the box syntax in our store HTML file. So here we just put in event binding, right? Now we have two-way binding for the property cart quantity. Lastly, come to our cart component HTML file, and as you can see, this is how we were getting the updated cart quantity. Now we don't need this, right? So you can safely comment that out, or if you want, you can delete it. I prefer commenting out because you have it for future reference, right? You know what we did or where we came from, right? So now that that is commented out, we can now go and compile and see if our two-way data binding works. To compile, you know what to do. Those who went through Node.js, you can come back to your prompt and just type in ngserve, press enter, and your compilation will begin. For those who went through VS Code, just load the Node.js command prompt. Don't forget to change directory to your project directory and then type in ngserve, press enter, and your compilation will begin as well. Once the compilation is done, come to your browser and type in localhost 4200. Now let's add to cart and see if our two-way data binding works. So add to cart, add another one. So that's fine. Now this is where our two-way binding gets tested, right? So add, and you see that works perfectly, right? Okay. So this is how two-way data binding works. Now let's try something. What if we do not incorporate the banana in the box syntax? So let's come back to the store component HTML and let's just take away the two-way binding. What do you think will happen? So when we add from the store, that works fine, right? Try to increase in the cart. You can see it's increasing here, but cart quantity does not reflect the change, right? Because now we don't have that HTML line and we don't have two-way data binding as well. Now we can see how two-way binding works in order to help us communicate from the child component to the parent, right? So if we put that back, so I hope you've understood now how two-way data binding works. Any questions that you have, please feel free to post in the comments and I'll try to get back to you as soon as I can. Coming to the next part of our session, we're going to be discussing the Angular lifecycle hooks OnChanges and DoCheck. You may recall that we've spoken about how a component has a life cycle from the time it's created to the time it's destroyed, right? And we can respond to events that happen during the life cycle of a component using what are called life cycle hooks. Right? And life cycle hooks are interfaces that will define a kind of a prototype for a particular method. And the important thing is that there is one method per life cycle hook. Now we've already looked at one life cycle hook, which is the onInit life cycle hook. And of course, the method defined by that interface is the ngOnInit method, which you may recall we used in our store component in order to fetch data. Right? You may also recall that the ngOnInit method runs or executes after Angular has checked for input properties on the component. Right? Now, how does Angular check for input properties on the component? That is using the OnChanges lifecycle hook, which is the first lifecycle hook we're going to discuss today. So come to your card component TypeScript file, and we'll start by importing the OnChanges lifecycle hook. Here it comes from Angular core. So just put in there OnChanges. And once we've imported it, we need to then specify here that we are implementing it. So comma OnChanges, right? And then we can implement the method, which is ngOnChanges. Every method that is defined by a lifecycle hook is preceded with the letters ng. Okay, so ngOnInit, ngOnChanges, etc. Now this method takes a parameter. So I'm just going to call it changes, and that's going to be of type simple changes, which again is an interface that needs to be imported from Angular core. So put that in simple changes. We just put in here console.log changes. Okay, and let's specify a message here so that we know what this is when it displays on screen. So let's just say changes in input properties, comma changes. Okay. Now we don't need to compile. So come straight to your project, right click, click inspect, come straight to the console. And you can see here, we can see changes in input properties and we have an object, right? If we expand that, we will see that for each property, we have an object which is of simple change type. So simple change is the class. And then of course we have this object and we have properties here, previous value, current value, first change, true. Right, so this is the first change in each of these properties. And if we, for example, add to cart, right, and changes in input properties, and you can see now first change is false. But you may also notice that we do not get the change in items detected here, right, when we add to cart. And that's because the ngOnChanges method does not detect changes in iterables. We need to use a different lifecycle hook for that. We'll come to that later. For now, what we'll do is let's use some of these properties. Okay, so come back to your OnChanges method, and here we put in if changes dot cart QNTY, then console.log changes. Let's just take current value and previous value. I think that makes more sense, right? So current value, comma, changes dot cart QNTY dot current value. Okay. Then we can see the previous value as well. Console.log previous value, comma, changes dot cart QNTY dot previous value. So now let's go to the console again, and you can see here current value is 0, previous value undefined. Okay, now I'm going to clear this so that we don't have it so cluttered. Let's add again. Let's add an item rather, and you can see current value is 1, previous value is 0. Add another one. Current value is 2, and previous value is 1. Okay, so this is how we can use the OnChanges method. So coming to now why we couldn't see item using the OnChanges lifecycle hook. As I said, we need to use another lifecycle hook for that, as OnChanges cannot detect changes in iterable. So let's import that lifecycle hook, and that's called that's a capital D, DoCheck. And this lifecycle hook needs a class called iterable differs. Okay. We then need to mention here that we are implementing the lifecycle hook. So put in DoCheck there. And once we've done that, we can then inject the class into the constructor. So come to the constructor and put in a comma there. And let's specify here private. We need a parameter there, iterable differs. And then that of course is going to be the class that we specify here. So iterable differs. Right? Now we also need a property which we'll initialize. So put in here public items array differ, and that's going to be of any type. Okay. And like I said, we need to initialize that property. So we say here this dot items array differ equal to, now we'll use the parameter we specified in the constructor, this dot iterable differs dot, and we'll use the find method of the iterable differs class, where we need to specify the array we're looking out for changes in, right? Or the array we're monitoring changes in. So this dot items. Now the find method will return an interface of type iterable differ factory, right? And we can use the create method of that interface, which will result in items array differ being of that interface type, and the name of that interface is iterable differ. Okay, so I hope that's clear. Here we are saying this dot iterable differs. We're using the class, of course, and the method from that class to specify the array for which we are monitoring changes, right? And the find method returns an interface of iterable differ factory type. We can use a method from that interface called the create method, which will then result in items array differ being of that interface type. And once we have that created, we can then use what is called a diff strategy or the diff method on this property. So now we'll put in our ng DoCheck method, which remember is defined by the DoCheck lifecycle, or the lifecycle hook rather, right? This takes no parameter. We'll just say a console.log, or instead of doing that, rather, we'll put in a constant array changes equal to this dot items array differ is the name of our property dot diff. Okay, and then we specify this dot items being the array for which we want changes recorded, right? So this is the one that will show us the which will show us every change in the items array. Okay, so now we'll say here if array changes, right? And then we'll say here array changes dot for each item. Okay, so for each item is a method again. Where does the for each item method come from? The diff method returns an interface called iterable changes, right? And this method is from that interface. So we can use it now. It needs a parameter. So we specify here item. That's going to be of any type. Let's use an arrow function here. And now we can just say console.log change recorded, comma, item, right? Okay. So now let's go to our console. Just clear the console and refresh the application. And now you can see our if statement is not executed, obviously, because there's no change in item array, right? So let's clear this console again so that we have it clean. And now you can see change recorded. It will show us the item we added, right? So this is how we can use the ng DoCheck method in order to check for changes in iterables, and then of course act on that if need be. Right, so this ends our session on, or ends the part of our discussion today on lifecycle hooks. The last part of our session today is to do with Angular animations. So for that, we need to come to our app module file. We need to import a module. So import browser animations module from at Angular / select platform browser / animations. Okay, semicolon, and then add that module to the imports array. So browser animations module. Right? Of course, there needs to be a comma there after browser module. Now we have set up the app module file for animations. Let's come next to our cart component TypeScript file. And we will import the functions we need for the animation. So import. The functions we need are trigger, transition, state, style, and animate. Okay, and those come from Angular / animations. Now we need to put in the metadata for the animations. So that has to be within the component metadata. So after the style URLs, we'll put in the property animations colon, and then this is going to be an array. So open box brackets, press and enter after the opening box bracket, and we start with the trigger function. Right? Now the trigger needs a name. This name that we put here will be the name that we'll use in the view file of the cart component, which will then work with the trigger function to trigger the animation. Okay, so let's call it seen, unseen. And of course, now we'll start with the first state of the animation. So the first state we want is, remember we are creating a dismissible alert now. So either it's going to be visible or invisible, right? So seen or unseen. So the first state is going to be seen. And this one is going to have, of course, its own style. So here is where we use a style function. Okay. Then open curly braces within those parentheses and press enter after that opening curly brace. And now we'll put in the styles. Okay, so let's start with the width. And this is just CSS properties. So 600 pixels, comma, height. Let's give it 20 pixels, comma, opacity 1 so that it's visible, and background color. Let's give it a purple. Of course, you can choose whatever color you like. Now after that state, the next state is unseen, right? So put in the name unseen there, right? Comma, style, and open curly braces to put in the styling properties. So width will be the same, so 600 pixels, comma, height will again be 20 pixels, comma, opacity. To see how the animation works, we won't make the opacity 0. Remember, 0 is invisible. Let's keep it at 0.5. Later on, we can change it. And let's keep the background color something other than white. Why? So we can actually see that color, right? So let's say yellow. Okay. So now we finished with state and style. The next function we need to use is transition. So transition. So for transition, we need to specify the transition from, for example, seen to unseen, and then another transition for unseen to seen. So this one is for seen to unseen. Okay. Then open box brackets. Press enter after that opening box bracket. And now we'll use the animate function. We'll just animate for 1 second. Okay. Then put a comma after this first transition to put in the second transition. So transition for unseen to seen, right? And then open box brackets, press enter. Animate. Okay, I think there's a mistake here. So let's see where these are closing. This is the trigger. This is my transition, right? Yeah, so this is fine actually. So transition. Now we need to put in the next transition. So transition. And then the name is unseen to seen, comma, open box brackets, press enter after that opening box bracket. And here we'll use the animate function again. And here we'll say 0.5 seconds. Okay, let's just do this part again. So now that we finished with one transition, the next transition is for unseen to seen, right? So it's we'll have a kind of functionality where the user will of course click on a button, right? So then Either the alert will be visible or it will be invisible. For the animations, for Angular animations, you need to specify each transition, how long you want to animate it for. So unseen to seen, comma, open box brackets, press enter, and we'll animate this one for just 0.5 seconds. Okay. And that's our animation setup. Now, okay, I seem to have some extra brackets here. So let's just see. This is for the trigger function. And I think we don't need this one. Yeah. Okay, so now let's go to our cart component HTML file. And we need to first comment out this one because we're going to use animations now for that alert. And we start with a div. And within the div, we put in that name that we use for the trigger. So seen, unseen, and make sure it's the same name, the same spelling. And then we'll use a ternary operator. So for the ternary operator, we'll need, of course, a Boolean type property that we can evaluate. So let's put in the property. We'll declare it later. Is seen question mark. So how does a ternary operator work? The condition on the left side of the question mark is evaluated. If it is fulfilled, then we want to do something. So in our case, we want the seen state to fire or be executed, right? Otherwise, and that's with the colon, if the condition is not met, then in our case, we want the unseen state to fire. Okay? So again, this will be a Boolean type property. If the value is true, then we will have the seen state of our animation fire. Otherwise, we will have the unseen state fire. Okay? And of course, we'll give this div a styling class equal to seen, unseen. Okay? And that ends the div. Within the div, we'll have a button and we'll use the same styling. So button class equal to message btn, click equal to, we'll use another function which we'll define in our service, toggle, and this function will just toggle between true and false for the property is seen. Okay, that ends our button. And then we'll use Angular property binding with interpolation for our message to be displayed. Right? Now, of course, we need to put in this property and the function. So come to your track order quantity service file and let's put in the property here. So public is seen of Boolean type equal to false, right? And then and then the function toggle, we can put it down here. So toggle this dot is seen equal to not this dot is seen, right? So this will toggle between true and false every time the user clicks on that button. Now, of course, there's one more thing we need to do, right? Remember, the message is to be displayed when the user deletes all items from the cart. So here, if items.length equal to 0, we will say this dot is seen equal to true, which will then result in the seen state of our animation being fired. So we will see the alert or the message, right? Okay, so now that we have put in the property and the function, remember we have declared these in the service file. The cart component is not aware of them. We need to make them visible to the cart component. So come to your cart component TypeScript file and we'll put in the properties here. So just declare them here. Public toggle and public is seen, right? And then we need to inject these dependencies into the constructor. So this dot is seen equal to track or quantity service dot is seen, right? And this dot toggle equal to track or QTY service dot toggle. Okay. So just to sum up what we did, we first went to the app module file, we imported the browser animations module, and we added it to the imports array. We then went to the cart component TypeScript file and we imported all the functions we need for the animation to work, which are trigger, transition, state, style, and animate from Angular animations. We then put in the metadata, right, within the animations property there, and we have trigger, right, the name of the trigger, which we use in the HTML file to trigger the animation. And then we have a state for both seen and unseen. Right? Of course, you could name this anything. You could name it visible, invisible, right? And then call this visible and this one invisible. That's up to you. And then, of course, we have a style for each state. We then use a transition function, right, for seen to unseen. If you're using visible and invisible, then it would be visible to invisible and invisible to visible. And then, of course, we use the animate function, and that completes our animations metadata. We then went to the cart component HTML file, and we use the div here to put in the trigger name. And then we use a ternary operator along with this Boolean type property, which will be evaluated. And if true, then we'll have the seen state of the animation fire, otherwise the unseen state. That, of course, is our styling class. And then we have the button. As I said, we're using the same styling class. And we have a click event binding here, which will result in the execution of the toggle function. Right? Then, of course, we went to our track order quantity service file and put in both the Boolean property and the function toggle, right? And then, of course, we need to make the cart component aware of these two, of the property as well as function, and that's what we did in our cart component TypeScript file, right? We put in the property and the function, and we injected the dependencies. Now the only thing left to do is to put in the styling for our div. So come to the cart component CSS file and just put in the styling for that div. You can pause the video if you like to copy the styling. Once you have the styling put in, check for any errors. Okay, we don't have any errors. So we can go and see how the animation works. So let's clear this. Let's close this Chrome Developer Tools actually, because we don't need it now. So let's close Chrome Developer Tools. And now you can see, the yellow banner, right? That's coming from the unseen state of our animation, which means that is seen, the Boolean type is not true, right? Or rather it is false. Okay, now let's add to cart. Add again. Let's increase. Let's take this cart to 0 and see if our animation works. And there you can see the purple bar. Right, if you click on this, it'll go back to yellow. Right? Now, of course, we don't want to see this yellow. So you can just come back to your cart component TypeScript file, and in the animations metadata, just change that opacity to 0. Then the color really doesn't matter. Okay. So now let's go and look at this, and you can see we don't see that yellow banner anymore. Add to cart. Add again. Decrease. Decrease. You see the message, your cart is empty. Click on it, it disappears. Right? So this ends our session for today. In the next session, we will discuss synchronous programming versus asynchronous programming, and the very important RxJS or reactive extensions for JavaScript library, with special focus on Angular observables. Okay, so till then, take care, stay safe, bye.